started. Okay, chapter 6. We're going to take a look at organic compounds containing nitrogen. Okay, nitrogen. So far in chapter 1 through 5, we only studied what? Carbon, hydrogen, and what? Oxygen, and then some phosphorus. Okay, but nitrogen is another very important element in organic chemistry, especially in biological systems. Okay. Our biomolecules, small biomolecules, large biomolecules, and a lot of natural products that are later on used or developed into a medicine are all nitrogen containing. Okay, the reason is nitrogen atoms play a very important role in the interactions of enzymes, receptors, and channels, etc. in our cells. Okay, in our cells. So let's take a look. Chapter 6. These two types of nitrogen-containing organic compounds called amines and amides. Okay, amines and amides. First, let's review the bonding characteristics of carbon, nitrogen, oxygen. We have studied carbon and oxygen a lot, right? We know carbon always have what? 4 bonds. No matter you have a double bond or triple bond, total number of bonding has to be 4. Oxygen, 2 bonds. Can be 2 single bonds or what? A double bond. Okay, those are we have seen a lot. Nitrogen, on the other hand, has 3 bonds in organic molecules. Besides that, okay, we have one thing we never mentioned about when we study oxygen. Nitrogen has a pair of electrons on it as well. Besides the 3 bonds, nitrogen has a pair of electrons that are not involved in bonding at all. We call that pair a non-bonding pair. Okay, a non-bonding pair. That pair of electrons is important for nitrogen, particularly because it explains the basicity of nitrogen-containing compounds. So keep that in mind. Okay, keep that in mind. Something we never talk about in oxygen because it's not really related to the chemistry we study about oxygen in this class. But nitrogen, we have to point out, besides nitrogen with 3 bonds, there's 1 pair of electrons, like these 2 dots, that are not involved in bonding. That will explain a property, a chemical property of the nitrogen. We'll mention that when we're there. Okay, so first, take a look. Nitrogen, when bonding with 3 hydrogens, gives the simplest nitrogen-containing molecule called ammonia, NH3. Again, nitrogen has what? 3 bonds. If they're all 3 hydrogens, that's the simplest we can get. We call that ammonia. Okay, ammonia. It is inorganic. It's not organic compound. It doesn't even have carbon. Good? You can buy ammonia. Okay, it smells terrible. You can buy ammonia, a bottle of ammonia for cleaning purpose. But if you replace one of the hydrogens, at least one, with what? With a carbon, with a group, then you get an organic molecule called an amine. Okay, called an amine. So what is amine? Replacing a hydrogen, at least one hydrogen, with what? With a carbon in ammonia, NH3. Okay, like these 2. This is replacing with a methyl group. This one is replacing with what? With an ethyl group. You get an organic compound called an amine. Okay, an amine. Now, depends on how many hydrogens are replaced with our group, with carbon-based group. we can classify amines into 3 types. Okay, a concept which is very similar to the one we learned before, right? If you replace with one group, R, we call the amine what? Primary. Then the nitrogen will be NH2, if you notice that, right? Because 3 hydrogens, remember. If you replace one with R, then there are how many hydrogens left? 2. So for amine like this, it's called primary amine. If you replace with what? 2 R's, then the nitrogen will be what? NH. We call it a secondary amine. Again, sometimes secondary people put a 2 and a little circle, superscript circle. And of course, if you replace all 3 hydrogens with 3 R groups, we get a tertiary amine. A concept we have seen before, but a very important comparison here, guys. Some of you may get confused, and some of you even get wrong for the first test. Even though the concept is the same, but when we classify amine versus when we classify alcohol, these 2 molecules are a little different. When we classify alcohol, we don't look at the what? We don't look at the O. We look at what? The C bonded to the O. So in this case, for example, on the C, there are 3 groups. We call the alcohol what? Tertiary alcohol. Take a look at this amine. They're doing this almost the same, except OH now becomes NH2. Take a look. When we classify the amine, we don't look at this carbon. We look at what? Nitrogen. Do you guys see that? On this nitrogen, there's how many groups? 1 group. You see that? Only 1 carbon bonded to the end. How do we know? Because there's 2 hydrogen on it yet, still. You guys see that? Then we call this amine what? Primary amine. That's the biggest difference. The concept is the same, but you look at different atoms. For amine classification, you look at what? Nitrogen. Okay, you look at the nitrogen. For alcohol classification, you look at what? The C. That is directly bonding with what? The O.
So the naming, it says tertiary butylamine. So the tertiary is for the carbon, correct?
Yes. T-butyl. This is for the group called the T-butyl because that carbon is tertiary. Okay, that's called the carbon is butyl, but the amine is primary. Okay, very good. Don't worry about that. That's a common name. We don't name it that way. Okay, don't worry about that. Good. Next. The amines can also be cyclic. In this case, the nitrogen will be part of the ring. If nitrogen is a part of the ring, that means what? At least there are 2 carbons on it. Otherwise, you cannot get a ring, right? If nitrogen is a part of the ring, at least 2 groups are on the nitrogen. So cyclic amines will only be either what? Secondary or what? Tertiary. Depends if you have a hydrogen left or not. If you have hydrogen left, secondary. If you don't have hydrogen left, like this one, is what? Tertiary. But it's also very common. As a matter of fact, cyclic amines are very important in natural products. Before we start naming, I'll give you a few examples how important they are and show you a few examples, structures of molecules you have heard or not heard of. Most of you have heard of it. The first molecule, take a look, is histamine. Have you guys heard of histamine? It's a very important messenger molecule in our nervous system. Okay, it's a messenger. We have histamine receptors. We have histamine 1 called H1 receptors. We also have H2 receptors. Okay, H1 receptor is responsible for what? For allergy reaction. H2 is responsible for hydrochloric acid secretion in your stomach. Okay, we have both inhibitors. H1 inhibitors, you guys probably taken before. What's that called? The one you take for HE user? Benadryl, yes. That's H1 receptor inhibitor. That H stands for what? Histamine. Okay, also I don't know if you guys taken omeprazole or Nexium. If you have heartburn, okay, that Nexium oh sorry, not one, I'm sorry. Famotidine, have you guys Pepsid AC? Pepsid AC. That one is H2 inhibitor. Famotidine or some of all the medicine waste. Nexium is different. Nexium is a proton pump inhibitor. Okay, but again, this is the structure of histamine. Okay, you can see that this molecule contains what? 3 nitrogens, right? We have a primary nitrogen here. We have 2 what? Cyclic nitrogen here. This nitrogen is tertiary. This nitrogen is secondary. Do you guys see that? You see that? Primary, secondary, and tertiary. There are 3 nitrogens. Okay, this guy, have you heard of this? Have you guys heard of this molecule? Serotonin. It's responsible for your mood. Okay, sometimes sleep, appetite, and sexuality. This is also a nitrogen-containing compound. Okay, also an alcohol, of course. This is a phenol. Okay, I'm sorry, not alcohol, phenol. Okay, the classification of this amine is primary. This one is secondary. Okay, secondary. See that how nitrogen plays a role in our system. These are just a couple of examples. Next one is a group of 3 compounds. Okay, 3 compounds. They're related structurally. You can see they're very similar. Okay, the first one is the dopamine. Okay, you guys have heard of a dopamine, right? Second one is norepinephrine, and this one is epinephrine. And you can see their structures, how related they are. Okay, if you put OH on the dopamine, you get norepinephrine. If you put a methyl on the end for norepinephrine, you get what? Epinephrine. The difference between norepinephrine and epinephrine is what? That methyl group. That's why it's called a norepinephrine, is missing that methyl group.
Can you be allergic to one and not the other?
I'm sorry?
So the epinephrine, can you be allergic to one and not the other?
Allergic, I don't know. I'm no expert on that. I don't know. Okay, epinephrine is a medicine. It's a drug name. Okay, internally we call it adrenaline. Okay, adrenaline. It's released by our adrenal glands. Okay, epinephrine is very commonly used in hospitals. Okay, you guys will use that too. I'm pretty sure, no matter which department you're going to be in. All right, so again, take a look at the structures. You get an idea about how important these nitrogen-containing compounds are. And as a matter of fact, a lot of natural products are also nitrogen-containing because they can potentially interact with similar receptors in our biological systems. Okay, so with that, let's take a look at the naming. Okay, after we finish naming, we probably can stop for the first part of the chapter 6. Okay, naming. Now, naming amines, a little bit, not complicated, but one extra step is we have to first tell the classification of the amine first. Because primary amines are named differently than secondary or tertiary amine. Slightly different. Okay, first, let's take a look at primary amines. Again, how do we recognize primary amines? The easiest way is to take a look at the nitrogen. The nitrogen should be what? NH2. Okay, NH2. If you see a primary amine, the naming is very similar to alcohol, if you still remember how to name alcohol. That is what? Find the longest chain that with the carbon to which the nitrogen is attached to. Again, we're still naming carbon chains. And then you change the alkane name to let me rephrase it. Then you need to drop the E of the alkane and change it to amine. AMINE. And finally, locate which carbon is the nitrogen attached to. Just like alcohol, you can see it's very similar. Okay, alcohol, the only difference is you need to drop the E, change it to what? To OL. Other than that, it's very similar. Okay, this one, 4 carbons, butane. You drop the E of butane and change it to what? To amine. Becomes butanamine. And then the 2 in front of it tells what? The amines attached to what? Number 2 carbon. That's it. That's the same, basically the same as alcohols. Does it make sense, guys? And this molecule, longest chain, 4 carbons. This is number 1. So 1 butanamine. And besides that, these 4 carbons, there's a methyl on number 3. So 3 methyl 1 butanamine. And keep in mind, there must be a number in front of the name. Okay, in front of the name. For secondary and tertiary amine, there's a little difference. Okay, a little different. That is, we know secondary or tertiary amine, there's what? Multiple groups on the nitrogen. Is that right? Secondary amine, how many groups? 2 groups on the nitrogen. Tertiary amine are 3 groups on the nitrogen. So you have to choose the longest one as the parent chain. Does it make sense? There are multiple groups. There must be small ones or big ones. You choose the longest group, the big group, and use it as a parent chain. Then the other group, you can use it as a group on nitrogen. You can list it as a group on nitrogen. For example, take a look. This example is the simplest one. This is a secondary amine. You guys see that? 2 groups. This is the longer group. That's a smaller group. So I use the longer group as what? The longest chain. 4 carbons, butane. Drop the E and change it to amine. So what? Butanamine. And then the nitrogens are attached to number 2 carbons. So 2 butanamine. That's the same. The only difference is now you have a small group that's on what? On nitrogen. So you have to tell people, hey, there's a group on nitrogen by using what? N. Means the methyl is on what? On nitrogen. Not on a carbon, but on the what? On nitrogen. So the name is N-methyl 2-butanamine. Does it make sense, guys? Okay, that's the only difference. Other than that, everything else is the same. Okay, I'll give you a couple of minutes to take a look at the names of the rest of the 3. Okay, should make sense. If not, I'll explain. Does it make sense? The rest of the names for the rest 3. Okay, take a look at the last one. There are methyl groups on what? On number 2 and also on number what? On the nitrogen. So you put 2N dimethyl. Okay. This case, N is kind of like a what? Like a number. But it's not a carbon, so now we don't number it. We just put what? N. Between the 2 N is a comma because N is kind of like a what? Number. Because it tells you where this methyl what is. Is that right, guys? Does it make sense? That's how we name secondary and tertiary amines. Okay, tell people if there's a group on N, you just use that N as a number because they're, again, these are not on the chain of the carbon. They're on the nitrogen. Okay, the N is a locator. You still treat it as a number. Good? And finally, when you have a NH2 attached to the benzene ring, you guys have seen the structure in chapter 2, right? It becomes a new parent name called alanine. Okay, alanine. Okay, A-I-N-A-N-I-L-I-N-E. Ian. Aniline. And if you have that parent name, that carbon is always number 1 carbon. So just name based on what we studied before in chapter 2. Okay, that's 3-chloroaniline or M-chloroaniline. This is 2,3-dichloroaniline. That's it for naming amines. Okay, let's quickly finish physical properties. Okay, very short. And then we focus on reactions next time. So we have finished the small part of this chapter. Okay, we have still have 10 minutes. Right? So that's all again for naming. Okay, very quickly for physical properties. Okay, I'll discuss with you later what do we know about it. But very quickly, that's the last one actually.
So
Okay.
I have a question in the secondary and tertiary naming.
Yes.
The last compound,
This one?
yeah, 2, N dimethyl 3-pentanamine.
Pentanamine, yes.
So we didn't write N first. So if there's another methyl group, see, like it says 2, N, so it's indicating 2 methyl groups, correct?
Yes. The 2 means there's methyl on number 2 carbon. The N means the methyl is on nitrogen.
So if I write N, 2, that would be wrong.
Oh, that's fine. No. I mean, I even don't know. I guess they put numbers first and then numbers, but that's no difference.
Okay.
Yeah, those 2 are just locators. Okay, you can put N, 2, I guess the same. For me, it's the same. No, I don't see any difference. Okay. The only difference is for the group name, you need to list them alphabetically. Okay, that's why there's called N-ethyl, N what? Methyl. They're not the same group. That's why you don't put N and N together. See that? These are the same group, methyl and what? Methyl. That's why you put N, N. Okay, they still need 2 N's because they're what? 2 methyl groups. Okay, we said each group, one number. One group, one number means what? You have to tell people where each group is. That's why these 2 methyl, you both have to put N and what? N, because they're the same group. That's why you put N and N. This case, this is ethyl group, this is the methyl group. They're not on the same nitrogen, but they're not the same group. So you still list them like this. N. Yeah, but here, 2N and 2, the same. I don't see any difference. Great. Like I said, very finally, before we end up the first part of the chapter 6, is very brief about the physical properties. Okay. Amines, okay, especially smaller amines, has very sharp and penetrating odor. Most people don't assume are unpleasant. Very similar to ammonia. If you guys don't know what ammonia smell is, go buy a bottle of Windex or just buy a bottle of ammonia. You can buy it, a diluted solution. It doesn't smell good. Most people don't like it. Okay, for smaller amines. For larger amines, they smell even worse. Okay, smell even worse. Similar to the odor of decaying fish or decaying animal bodies. Okay, I don't know if you ever smelled that. If you have a dead animal body on your backyard or on the road for long, if you're getting close, you get the idea. They're because of decaying proteins to generate these like large amines. Okay, these are from breaking down of proteins. Okay, proteins are nitrogen-containing compounds as well. So because of the natural breaking down, we generate the large amines. Again, normally amines don't smell pleasant. Okay, don't smell pleasant. So that's all. We don't compare the physical or boiling point or water solubility of amines because again, amines compared with other organic molecules, they can be primary, secondary, or tertiary. Their structures are very complicated and varied. So that's why we don't study their physical or their boiling point or water solubility in a systematic way. But in general, amines, their water solubility and boiling points are similar to alcohols, but slightly worse. Okay, for example, amines are less soluble than alcohols. Amines are less, like a boiling point is slightly lower than alcohol has as well. Okay, generally speaking, because nitrogen is less polar than, NH bond is less polar than OH bond. Okay, that's the main reason. But again, if you want to compare, amines are close to alcohols, but slightly lower. But again, because amine can be primary, secondary, tertiary, so it's hard to define based on the structure of amine and also based on the number of carbons itself. Okay, consider many factors. That's why we don't, in this class, study their physical property systematically like we did before. All right, so that's all for the beginning of chapter 6. We'll continue on Wednesday on the chemistry of amines. Okay, thank you guys. I'll see you on Wednesday.